Alright, you ready?
Yep, I'm recording on my side, so you're good to go.
Cool. So I'm gonna go ahead and get started by screen sharing and showing off. Let's see. I'm gonna show off the repositories that you guys should be aware of. And I can drop these links in voice general as well. So the two big ones are Spaces VR. I'm sharing the right screen, right? You see the GitHub repo? The Muse ideas, yeah.
Yep.
Okay.
Yeah.
So yeah, there's two repos. There's Spaces VR and Muse ideas. So quick intro on Spaces VR. Spaces VR is sort of the tagline, a standardized reality for the future of the 3D web. So it's basically your building blocks in your environment to be able to build all your worlds in. And an important note is that Muse is built on top of this, right? So you can see the actual lines of code looks something like this. It's very, very, very straightforward. The entirety of your player, your cursor, your the controls, the compatibility on mobile, desktop VR, that's all encompassed in this one standard reality component. And then all of your content of the world goes underneath it, or inside of it, rather. And that's good to know because literally the way this is all structured is the way this is all structured is really just like you have your reality as your container, and then you have ideas that just get placed inside of it. And this idea keyword is something that we created in Muse because we can't use the word component because that sort of conflicts with the React components. You'll see how that naming convention might get a little confusing. But ideas are sort of like the fundamental building block for what you can add or remove from your world. So that's, you've probably seen that throughout some of our verbiage of like the interrogator idea, the model idea, and everything. It's basically something that you can add or remove from your world. And again, Spaces VR provides the sort of fundamental layer to then build on top of. So you can really just think of like very abstractly the reality here is provided by Spaces VR. And then these are all individual ideas where we're about to develop one of our own. Is sort of the goal here, right? And again, just to sort of drive that point home that everything is an idea on the Muse repo, if you go into the source here, I actually copied over some of the ones that we're using in production that you guys actually have access to, such as, I don't know, that's an easy one. Yeah, ETH transact button, right? So this is the one that lets you accept transactions with Ethereum. And this is the raw source code, right? And I'll show you guys, obviously there's a lot more code than we'll be able to cover today, but just to sort of prove the point that things you can add or remove to your world in the Muse Builder is a one-to-one mapping with things you can add or remove to your world in these folders here. So to go through a few more. Oh, this is the lost template source code. It's very straightforward. It's literally just you can sort of skim through it. You have an ambient light, directional light that's optional, a background that's a color that you specify, has some particles, fog, a mesh for the floor, and then a collider for the infinite plane, right? Pretty straightforward stuff. And yeah, like I know there's probably a lot of syntax things here and there that are confusing, but just sort of, again, prove the point that this is really all the makeup that we structured with Muse, is you have this overarching reality provided by Spaces VR, this repo here, and then individual ideas that can be added either from us through the builder or from you when you code your own. Walton, as you join, just a heads up, feel free to jump in whenever and ask any questions. I'm going to be going from like a zero to hero on submitting your own plugins. And what's up, Matthew? And this is also being recorded in case you want to go back and see anything. But welcome, you guys.
Happy Wednesday.
Happy Wednesday. Another thing I'll point out of Spaces VR is there's a lot of useful tooling in here. This will sort of become more relevant once you actually start to develop your idea. such as this floating component will make anything that's a child of it just float up and down, right? Pretty straightforward. This interactable modifier will make it so that when you click on stuff, it'll respond. So it'll output to the console. You can open a new tab. For example, this same modifier is how we get the link buttons to work. So because of that, right, because we have Spaces VR as a resource, you'll probably be referring to these documentations a lot. But obviously, when you go to develop your idea, you can feel free to message me or ask any questions, and I can help you point in the right direction for what you need to know. But I'll stop here really quick. Any questions on sort of the map of the infrastructure and how it's sort of laid out?
No, so far so good.
All right, and again, just to drive this point home, if you go into source and ideas, there's tons of examples here, and we're going to go through the process of submitting a new ones, right? So again, if you're building a Muse world, we have tons of ideas at your disposal. But now, let's say you client wants something custom. Let's say for one of these ones that are available here, I don't know, decorations like the wall, right? Oh, you want the wall to be slightly thicker, so you want to make your own, right? You can do that, right? Because all this source code's here, you can copy and paste it and just change it however you want. So let's sort of run through that process. Really, the only thing you'll need is VS Code and a GitHub account. So if you don't already have that, keep that in mind, GitHub account, VS Code. And what you're going to do is you're going to click this button here that says fork. If you guys aren't aware, what forking does is it'll take this repo and sort of make your own version of it, so you can start committing and modifying the code base, and then you're going to sort of create a pull request once you're ready, and once the idea is ready, that's going to basically try to merge it back into the original repo. And we'll see what that process is like, but that's kind of what's going on. So I'm going to hit this fork button here. I can just leave it how it is. Leave this how it is, doesn't really matter, and hit create fork. So now it says up here, I'm on this repository alex_short/muse ideas. So this is sort of my working version, as opposed to the one that's sort of the master copy, the Muse HQ version. And once I'm here, I'm going to actually start working on this. If you guys don't know too much about GitHub or VS Code or the terminal, I'll sort of gloss over those things, and you can feel free to reach out, and I can point you to some tutorials and stuff. But yeah, so let's just go into desktop, and we're going to, just in case you want to just blindly follow along, code SSH copy, and you're going to run git clone and paste that URL. And what that did is that copied this repository locally into my desktop. So now if I open my desktop, you'll see I have the Muse Ideas folder copied in with all the same files. So now if I open up VS Code, and I point it to folder, desktop, Muse Ideas, and open. Yes, I trust myself. Now we have the files ready to start working here, and you can see if you had two ideas, and you get all the source code that we were seeing in the GitHub file previewer. And it's ready to start working on. So again, I'll sort of gloss over Git concepts, but you can start making commits and then PR once you're ready. So let's maybe start working on an idea, and I'm just going to do one that I have over here. Oh, that's right, yeah. So I was going to show off what it's like to import a model and display that, because I know that's probably something that'll happen pretty often for you guys. So let me make, what's the plan here? Why don't we make a model? And actually, I was going to pull one off of here, kind of like this duck. We're going to have this duck, and we're going to have it, when you walk up to it, it's just going to show up, and then if you walk away, it'll go away. So it'll be kind of like the proximity model, or proximity media idea that we already have, but for a specific model, and then we can maybe add some flair once that basic functionality working, see where it takes us. So now that I have an idea sort of what I want, I'm going to go into back to VS Code. And inside of ideas, you can sort of see I'm like organizing these by, I don't know, this isn't standardized by any means, but just sort of like whatever you think it fits. So for what I just said, I don't know, decorations, it's kind of a decoration, right? Little duck that appears and goes away. So I'm going to make a new folder, call it hiding duck. And I have some of this laid out in the Muse ideas README, but so you can use that for reference in case you forget some of it. But I'll just sort of go ahead. The first thing you're going to need is this idea JSON file. So what I tend to do is just copy and paste one from one of these other directories. So I'll just copy this one and drop it right in here, and then start editing all of these to match what I need. So to start off, predecessor and ID you can just remove, because those will come later. The name, we'll sort of give it hiding duck, the one we were working with. Purpose, you can just sort of leave blank for right now. And then schema, the big thing, this is probably the most important one out of everything. These fields are what actually synchronizes with the builder tools. So you see how we have, let's say, type number, type image, type boolean. That's a one-to-one mapping for the different input types in the builder tools inside of Muse HQ. Or sorry, the builder tools in your builder, right? So if you are trying to make it actually work with the builder, you should actually pay attention to this. You can also just, if you really want to, alternatively, completely remove it and submit it. And when you add it to your world, you'll be able to add or remove it, but not do anything else to it. So, I don't know, in some cases you don't really care, in some cases you do. But I think the standard ones will tend to be position, rotation, and scale, so you can at the very least move it around, right? Get it the right sizing. So let's maybe give it that. We'll hide the other ones for now. And then we're going to also remove this for now. Well, we'll wait for that in a second.
I would be so nervous if no.
So this is like a pretty standard idea.json, and this is important to have here because you'll see when we're actually building our idea, we have a little development environment that will let you actually tweak these on the spot, these values on the spot, which makes it really easy to develop and test that everything's working. And we're also going to add now a dummy index.tsx. So two files that you want off the bat are idea.json and index.tsx. These are like the main two, where this is sort of like the metadata, and this is sort of the actual code that's going to be running. So I copied it over, and I'll sort of leave a boilerplate. And actually, what I'll probably do, Steven, if you don't mind writing a little note in Slack or whatever, I should have a boilerplate, like a starting point file somewhere, or maybe like a command to generate these files, just so that everyone has a starting point. But
sounds good.
Thanks. But let me just do this really quick. So that.
Palestine-Israeli conversation part 2.
One thing I forgot to do. So now that I actually copied over the repository, I need a cd into it, cd ideas, and then run yarn install to install all the packages locally. We are using yarn as a package manager, yeah, obviously to get this working locally and to be able to run it locally, you're going to need yarn, npm, node, all the above. And again, I can point you to any tutorials in case you're unaware about those concepts. But yeah, so once we get all of this, I think this is actually, we're one or two steps away from actually having everything figured out. So we ran yarn install, and now we're going to run one more command, which is, now that we have this idea.json file here, we can run this command yarn sync.
Congratulations, Pepino. It's August 15th.
That's going to create a page file that corresponds to this idea file, and it's going to look for this idea.json file. You can also create it manually, and you can see if you sort of peruse through a couple of these, it's basically all copied. There's not really much. I think the only thing that changes is literally this word right here. I guess these two. But this will actually just serve the idea so that you can develop locally. It's a little housekeeping, but yeah. again, I have a better lay of the land inside of the README in case that was a little bit of a confusing order to do things. But once you have the yarn sync done, you have the yarn packages installed with the yarn install, then you can run yarn dev. And that's going to start a local development server serving all of the different ideas that are in this repo. If you go to copy and paste that URL, so localhost 3000, you'll see 404. And that's because matching with the pages folders here, you actually have to sort of navigate to this one idea. So if I want to show the hiding duck, it's going to be localhost 3000 / decorations / hiding duck, all with the same casing. Take a second to build.
Yeah, it's Semester at C1. One from Semester at C.
And there you go. And you can see inside of index.tsx, I'm not returning anything. I should probably explain what some of this means, but a group, if you use HTML by any chance, it's the same as a div. It's sort of like a container. It doesn't actually return anything that you can see or interact with. It's just a way to sort of group things together, right? Pretty well aptly named, but yeah, that's why it's blank right now, and I have just a ground so you can walk around and have a sense of where you are. But you can see that this position rotation scale up here, and this information is being pulled from idea.json. So that's what I was saying. It matters. Let's say you want to add another parameter like I don't know, radius, and then we'll have the type number. Then it will show up here, right, as a new input we can sort of work with and change. And the values will sort of be streamed live into the actual source code that we have for the heading duck. Okay, so I'm pretty sure I covered everything in terms of setup, and I know that was a little not straightforward, but any questions so far on how I got here? Anything unclear before I start actually coding out the functionality for the hiding duck idea? Yeah, and by all means, this is like a one-time, most of what I covered is a one-time setup, so feel free to reach out, feel free to ping me in the Spaces VR channel or the developer channel or whatnot. I can help you get set up, but with all the one-time setup stuff aside, you should end up at this place where you have, you now have two windows, right? You have your development server that's sort of showing off your idea that you're working on, and then you have your source code that you're going to be actually working on. So let's maybe start implementing stuff. So now that was all the sort of housekeeping for creating the boilerplate for the idea and sort of getting a starting point, and now we're sort of transitioning into okay, how do you actually go about coding what you want to build? And one thing I'll cover here that I'm not sure if it's obvious for everyone, but this is all built on top of a library called React Fiber, if you guys weren't aware. And this is, there's like a couple of layers of knowledge here, but this is a library that combines, obviously, 3JS, right? So this is all built on top of 3JS, and React, right? So those are the two main concepts, as per the name, that you should probably be somewhat aware of, right? Again, like kind of the reason that we chose this from the get-go was that it's a very easy language to understand and get comfortable with, just because of the way, like, I'm sure you guys can sort of you might question exactly how this works and exactly how it operates, but you can pretty reasonably guess what's going on here, right? It says ambient light. Yep, as you guessed it, there's an ambient light in the scene. There's a point light in the scene with a position of 10, 10, 10, right? It's pretty readable, which is why we picked it. So there's definitely like a lot of intricacies, especially when you're trying to create some pretty advanced infrastructure. But I would recommend to just sort of like go for it. Just try things, right? Like you have an unlimited amount of refreshes you can make on your idea, so don't be afraid to just copy paste stuff. And by the way, that's actually the reason why we have this repo and the reason why we're all sort of contributing to one. is because I do really want to encourage people to copy code. So don't feel afraid to copy stuff that you find here. There's code, some useful things I can sort of point out here and there, things like in the button, what's good here? We have like a function that will open a new link in a new tab, right? Which is kind of nice. We have a mesh with the box, right? I don't know. I think we have proximity media here. If I'm not mistaken. Yeah, proximity media. So we can actually, even when we're building the hiding depth, we can sort of rip out the functionality of, okay, how did I make it show or not show? And you can just sort of like inspect the code and take whatever you need. By all means, feel free to do that, as well as, we have 3 plugins. So to touch on that really quick, in terms of the phrasing, plugins are sort of refer to third parties implementing their own infrastructure into Muse. So you can see the 3 examples of Zesty Market and their NFT ad space placement, Drop Party NFT Gateway, and the Easily Buy button for actually minting NFTs on a website, right? And yeah, their source code is available, right? Because nothing's really sensitive here. This is just sort of talking to their own backend, and they have just some code to display, in this case, display a banner ad. And actually, it's kind of funny is the Easily guys, they actually took the code for the ETH Transact button, right? So they actually just ripped out the whole thing and then modified it to their own needs. So definitely we have a culture here of sharing code. We're not really stingy with it, but I do understand, by the way, if you guys spend a lot of time working on something and you do want to privatize your code, so just contact me if you do want to go about that. We can set something up. But yeah, let's get started. So the functionality we're going for again is a duck that's just gonna kind of like proximity media, that's gonna hide itself if you come near it, I guess. I haven't really thought this through too well, but yeah, let's run with that. If you walk near it, this duck is just going to go away. So let's maybe start by trying to load in the duck. One more thing I say before we get into it is that I'm going to be sort of building this out specifically, and again, there's a lot of directions you can take from this sort of like initial starting point, so I probably won't touch on everything you might need, but hopefully there's some good stuff here. So I'm just going to copy the direct link, and right off the bat, there's this hook called use GLTF that's exported from React 3 Dre, which is another really useful library that's in the React 3 endpoint monitors ecosystem. So you can just sort of say import use GLTF. I think I have the casing wrong. And then you can import it just by saying const GLTF is equal to use GLTF, and then the URL file that I copied from there. And what's going to happen now is we have a GLTF that will be loaded from this URL into memory. And nothing's going to show yet because we're not actually putting it on screen. In order to do that, we need to use a primitive object, or is it? It's a primitive tag. You can pass in an object called gltf.scene. So it's going to take, we're glossing over a lot of concepts here, but the gltf will return a lot of data, and the scene is sort of the actual, it's like the actual code or the actual data for the model that you're loading in. And a primitive is just a way to sort of put in a very basic component from 3D, right? So you can throw in anything into the object part of the primitive. Honestly, not the best way to go about it, and it's actually not showing. Should be showing points, so I'm a little uncertain as to what's going on. But do not fear this. We have Blender. Actually, what I'm realizing would be better. Yeah, let's do that. Okay, so already I'm going to take some code from this. I know I have a component around here somewhere. Oh, do I not have it? Oh, I think I have it. Okay, we can inspect what's going on here. Oh, and I already know what's going on here. Okay, so the scale is set to 0 here. That's my bad. There. Okay, we have a duck. Okay, so pretend that was set to 1 the first time. So basically, you load in the useGLTF, load in a GLTF using the useGLTF hook, and to reference the actual data, you use gltf.scene and pass it into this primitive component. And that will put a 3D model into space, right? So this already is a good boilerplate as to how to load in 3D models. And now this is your F3 Fiber, and I can show you maybe some basics of things you can do with it. So first of all, I mentioned at the beginning, groups are kind of like divs. You can just sort of throw them around the place. You could add, I can add as many of these as I want. It's not going to change how it looks like. But what it lets me do is it lets me sort of individually tweak with different transformations, right? So let's say I want to set the scale of this to 0.9. It's going to locally scale it by, obviously, 9 or 0.7. Make sure you hit save. Yeah, so every time you hit save, it should automatically refresh, right? One important thing to note as you're working with this is that all the transformations you can apply, so position, it all sort of works in the order that you define it. So let's say I have a scale 0.7 and then I move it up 0.6 or 0.7. Let's save. And then I scale this guy here. 3.5. Now it's going to scale it with Now it's going to scale it with an offset position, which probably isn't that obvious what that looks like, but actually if I scale this guy, it'll make more sense. You can sort of see that it's not quite scaling at the center, right? It's scaling just a little bit offset because I have the position a little ways down from the scale here. So anyway, that's one thing to think about groups is that the transformations apply in the order that you define them. And sometimes we'll have to walk through like, okay, the primitive GLTF here is going to have 0.7 scale. It's going to move it up, and then again, it's going to scale it with the new center of the transformation being at 0, 0, right? So just a little gotcha there out of groups, but yeah, pretty straightforward there. Now let's write some code to detect whether the player is nearby. Any questions on that so far? Yeah.
How does it affect draw calls and stuff? And like loading times? Is it like the same thing?
Groups will not affect draw calls.
Sorry, my bad. It was from a further back thing. I completely forgot to put the context in. But say when it drawn from the direct link from, I guess it was when you were gonna do it the other way with the direct link. Would that still like do the same exact loading as it would if you just had the model in?
Are you talking about if I were to use this direct link right here?
Yeah.
Yeah, so
it's like downloading it to Muse and uploading it to like the.
Oh, you're just saying. No, that will not affect draw calls. That will only affect like where the data comes from, which might affect, let's say, network speeds. It could affect file size, right? Because Muse has some infrastructure to compress files when you go to upload it. Those are the things that might compress, but it won't, or it might change. But besides that, it won't affect draw calls. No.
Okay.
Yeah, and actually, thanks for pointing that out. We do have this little tool up here so you can sort of see all the different metrics that you might care about. Keep in mind that in terms of draw calls, there are some things already in the scene that are taking up draw calls. The floor takes up 1, and if you press G to see these axes, that takes up, 3? Right, yeah, one for each line. So it says 10, but might subtract 4 for 1 for the floor, 3 for this guy. So this guy is actually 6. But yeah, okay. So let's keep going with adding that little functionality, and then I'll sort of move on to the props here. And again, just to sort of add this caveat again, I am not working off of any sort of curriculum or anything like that. I'm just sort of like going forward with showing off one way to build one idea. and there's going to be 1,000 things that I'm not sort of glossing over. But I'm happy to, again, offline answer any questions and send you resources on how to learn or example code, either inside of Muse Ideas or if we have any lying around that we'd be happy to share. So yeah, don't hesitate to reach out for that sort of stuff. But yeah, I think it's a pretty common thing to ask for trying to detect if the players nearby. So let's maybe do that. You guys are familiar with React, you probably know about states. We're going to have one called near that will be initialized to false. And this will basically, forget, state from React. And like it says, the state will sort of keep track of whether or not the player is nearby to the duck, right? Pretty straightforward. And we need actually one more thing. It's going to be ref. We'll call it group. So this boilerplate here will basically allow us to have a reference to one of these groups, and you'll see kind of how that's used in a second. But I'm going to attach it to. I'm going to remove these guys now, so mostly just for show. So ref. Okay, so the duck is back how it was. I removed all the transformations, and I now have a local state that's going to help us keep track of whether or not the player is nearby, called near. And then I have a reference, which this little technique here, if you don't know, setting ref equal to this variable will allow us to, in the code, actually reference this exact group. And then you'll sort of see, in addition to that technique transitions us into the Three.js API, which we can then start leveraging to do stuff like getting its children, getting different properties of the group, moving around the group, right? There's a lot of fun things we can do there. And yeah, so we're going to do a use frame. So the use frame comes from React Fiber, and what it does is it will run a little bit of code every frame, right? Pretty straightforward. And here we're going to have a little delimiter that says if group.parent is not defined, then return, right? Meaning that sometimes whenever the component will initialize, this reference will not actually be attached. So we want to make sure not to actually run code until it's attached, right? And then we can start going. So we can actually get from the use frame some parameters, one of them being camera. And what we can start to do is there's a very easy function that says group.parent, which will now get a reference to this group right here, position distance 2, and just get distance 2 camera.position. A lot of this stuff actually comes from Three.js source code. So once you sort of transition into this more traditional programming syntax, you've basically transitioned into Three.js, as opposed to when you're in this JSX link here, with all the tags, you're still kind of in React land, right? So that's just a matter of like, and I'll even leave little comments here. This is all Fighter stuff, and this is all Three.js stuff. That's just helpful to know, just so you know where to actually go to look for documentation on all this stuff. So yeah, so I guess this doesn't make sense. Hopefully it's pretty straightforward. You're getting the current group, which is this guy here, getting the position, and getting the distance to the camera, right? And so now that's what this variable here holds. And then now it's going to be very simple. All you're going to say is set near. We'll say const is near for the local thing. And we'll say distance is less than, I don't know, just throw a number, 4. So basically have this local variable here, and we're saying if distance is less than 4, then they are near. And then you can set near to 0, right? And yeah, it's pretty straightforward, but you're just checking if the distance of the player to the camera is less than 4, and then setting this state over here. And I guess I could shorthand this, make it a little easier. now this near variable, this near state here, will always be synchronized with the information of is the player within 4 meters of the group. And then finally, let's actually do something with this variable. And we can do something simple like, it's kind of fun. Why don't we do scale and say, I'm just going to write this out and explain it. Oh, that actually worked better than I thought. Oh, okay, yeah, I see why it's doing that. We do 0.9. Cool. Yeah, so just to sort of run through what I just wrote, we have this distance variable here. That again is getting the distance to the camera, and then if it's less than 4, then we're setting the near state to true or false, depending on whether the distance is less than 4. And then over here, now that the state is sort of live and active, we can sort of use it down here inside one of the parameters for this group. And so now we're saying for scale, if it's near, set it to 0.5, but if it's not near, set it to 1. That's what that syntax means. And you can sort of see how that's working. So now if I'm within 4, or outside of 4 rather, 4 units, the scale is going to be 1. And then if I'm inside of it, it's going to go down to 0.5. And yeah, this is the sort of stuff you can do. Like, you can already see this is something right? Like, this is a pretty unique little interaction. And of course, I'm moving pretty fast because I know what I'm doing, and I know for you guys it'll probably be a little bit harder to catch on. But just to sort of say, like, I do want to really drive the with some Googling and with some copying and pasting, and there's plenty of resources online for a lot of this sort of stuff. You can get some really custom functionality, right? This is just sort of like one tiny example of that. And yeah, pretty straightforward, but that's what we got going on. One thing I'm going to do really quick. Yeah, let's do it. I don't think it's too important that I explain what's going on here, but or that you guys understand what's going on here. It's a little bit convoluted, but basically, the actual position of this group is sort of like the position that you set when you do position equals 0, 5, 0. And notice that that's relative, right? Like, this is 0, 5, 0, but if I start moving one of the parent positions around, then it will still move the duck around, just that this group, the position of this group over here will still be 0, 5, 0. So the more accurate thing to check is not necessarily group.current position, but it's the world position. And there's a little syntax for that, which is just saying group.current.getWorldPosition. And you pass in a dummy variable, and then you can just check against that dummy variable. So let's see, it's still working. And just to sort of prove that point, if I were to have done what I had before, group.current.position, it works fine when it's like this, but if I were to move it around, let's say move it like 4 on this axis here, it's not going to work properly, right? I can get right up to it, it's not going to work. And that's because the position is still 0, 0, 0, if that's what it's checking for. Then over here, if I put it back to how it was and use the world position that I grabbed, it's now going to actually get the world position of this duck, and then as I translate the idea around the world, it'll stay in sync with it. All right. So very simple idea, very isn't even necessarily a hiding duck, but actually, wouldn't hiding be opposite? If I come near it, oh no, that's right. If I get near it, it hides. Okay, cool. But yeah, now we're gonna pretend that this is exactly what I wanted from the start, and that it's ready to go. And we're gonna go through the process mission, see what that looks like. Any questions? I know again, this is a lot of specifics that I'm not really. The point of this isn't really to cover like specifics on React through Fiber, but hopefully you guys sort of see. I can paint a picture of like what it looks like to develop in this environment. Does that sort of make sense? Any questions on that? yeah, it'll be helpful with example code. I mean, to be just bluntly honest, half of my code is copied, right? Like what I do is I'm just very good at Googling. The best programmers are good at Googling. They just spend half their time finding examples online, and especially like that's one thing this community is in really well. So this all comes from Poimandres. It's a group that it's a open source developer collective, and they have a ton of library. Fiber, which is built on use canon for physics. What else do we use? The Dre library is another really big one. This is one, if you just sort of look through it, this has a lot of goodies, right? And this is actually sort of the inspiration for Spaces VR. You can see that they have very complicated things like, let me just go through this. Text 3D, I don't know, the USGLTF loaders, they have it all packaged up in a very easy to consume way to where you don't even have to be concerned about how it's implemented. And that's sort of something similar, like a similar mission to how I'm designing Spaces VR is to, you saw the example, right? You just throw down standard reality and everything works. So huge props to these guys that, designed these libraries in a very convenient way. And not only designing the libraries, if you scour around Twitter or Code Sandbox or these threads and the issues here, tons of example code that they're just openly sharing, and you can just, yoink it, put it in your own project, and you're good to go. Just to say that, again, most of your time will be spent copying and pasting from other people, and that's just kind of how it goes, and you'll make some really cool way. I guess one thing I'll cover here is, while I'm here, really quick, is what it looks like to add a prop. So we already have, if you go into ideas, decorations, duck, we already have position, rotation, scale, but we never actually used this radius. And let me actually, we actually have a list of types over here somewhere. In Muse ideas, on the README, we have a list of types that we support. Position, rotation, scale, media, image, video, blah, blah, blah. And one of them is radius. Radius is the one you guys have probably seen with, let's say, the video player and the audio distance, and like an actual sphere will show up in the world and match the number input that you're showing, right? So that's kind of the input that we want, because it's nice to have a visual to sort of show a radius of how far you can walk to it. So I'm going to set the type to be radius here. And now that this is set up, what we can do is hop over to hiding duck props and add it as a type over here, right? So this is sort of like the boilerplate if you just want position, rotation, scale as is. And again, Steven sent me a reminder, and I will of the starting point for just getting position, rotation, scale. But to start expanding on that, now you start adding stuff like, okay, so we added this radius prop. The name is radius, right? So I guess to not get confused, let's give this a different name, but I don't know, distance. This name here is one-to-one in terms of casing and letters with the variable that's going to be over here. Right, so distance is going to be a type of number. And then we're going to pull up distance in the props down here. And now this number will be synchronized with this distance right here. And we can start using it. So let's say for this 4 here, we obviously don't want it to, we want to be able to change this distance. So we just set distance right here. We just paste it right there. And then right now it's set to 1. So it's a pretty small amount, but now I can change it to, let's say, 9. And it'll live update. And this is, again, like a very rough idea of what it will be like to build to use your idea inside of Builder Tools. So it's helpful to have this around. As you change this number, it'll change live as well on the code that you're running, right? Cool. Okay, so I think that's pretty complete example, right? So there's an example of using a prop, position, rotation, scale, using local state, using use frame, which you'll use these a lot for sure. They're outrageously helpful. Cool, and I think I feel pretty good about this. So again, I told you you can skip over some of these, and you can completely skip over some of these. Feel free to let me handle it in the submission process, and we'll go through that right now. So I'm done with this. I'm happy with this, and what I can do now is I can actually, inside of instance has to be optional here. Yeah, that's one thing with the ideas and how we have it laid out right now is all of these properties will be optional because the default is has to be set over here. Yes, I'm glad I caught that. The default is going to be, let's say, 4. So if nothing is passed, it'll be 4, or if you pass in a number, then it'll be whatever you pass in. So just remember to have that. And all of these little gotchas, again, I will catch on the pull request. Again, like our infrastructure is not very built out, which you submit it, and I'll sort of help get to all these little things. So don't ever feel afraid to just submit it. It feels like half baked, because again, I'll through it. But yeah, okay. So this is a pretty complete example. I'm gonna go ahead and say created hiding duck, and then add all the files and commit it. So now I'm actually committing it to GitHub, and then I'm gonna push by hitting sync. So now back over in my forked version of Muse Ideas, if I refresh, should be a new commit. 17 seconds ago, created hiding duck, and it's good to go, right? So now I have this version of Muse Ideas with an extra commit. And in case you guys aren't aware, I committed to my version of Muse Ideas, but the actual production version of Muse Execute/Muse Ideas is still at 20 commits, not 21, because I committed to my own, right? And now I want to sort of merge the two together. And that process is as simple as going over to pull requests here inside of the official Muse Ideas. You create a new pull request, and then you can, that's not how to do it. How do you do it? Let me go here. Pull request, new pull request. There you go. Yeah. So you go to your own. Yeah, so just run that back. On your own version of Muse Ideas, you're going to go to pull requests. Oops. Pull requests. Hit new pull request. And it actually already, because it's a forked version, it already sort of assumes that you're trying to go into the master version, right? And you can sort of see there's exactly one commit extra, which is the one I made. And I hit create. And here's where you will start sort of filling out the info. So maybe say hiding duck idea, give it like a name. Duck idea. You can say this is for my world to add a hiding duck. Cool. And add some more info. Here's where you can say does the schema look good? Can you take a look at I don't know, index.tsx, right? So like any sort of feedback, this is like your direct way to communicate with me. If you guys haven't worked with pull requests, it's a very convenient way to sort of go back on like one exact piece of work. So don't feel the need to reach out to me on Discord. Free to start messaging up here, right? And you can leave comments here. You can ping me at Alex Short. You can do whatever you need to do, and it'll all sort of be encapsulated in the environment. And what's really cool is when you submit a PR, you can sort of see it's actually going to be building. And once that's done, you will have a live link of your idea. You can actually start sharing with people. So we'll let that build in a second. But once it's done, yeah, like let's say you're working with a client and you want to, you're working on a specific idea for them. Once you submit the PR, it will actually build a live link, and you can start saying that to them. I think I did that with one of the recent ones. But yeah, so you take this link, and similar to how you do localhost 3000 duck, you just replace, you take this visit preview, you hit copy link address, or you should click on it, I guess, and then you go to /decorations/hiding duck, and your code should be live and editable by anyone. And what's going on? Looks like we got a little bug. There's no duck there. Oh, right. The scale is still 0. Yeah, that's one thing on the development environment I need to fix. So apologies for that. I'll get that fixed in soon. But yeah, there you go. So now you have a live link you can send to people and remind them, hey, set scale to 1. But it should be going. And you can set this to something better like 6. Right? And you can see it's a link you can send to anyone. So yeah, that's pretty much the process end to end. I think I just sort of described it, right? And then from there, what the process would look like is I will help you and make sure all the files are fine. We'll here, and then once it's all ready, I will push it live, and then you can immediately add it to your Muse world. And we'll sort of pretend that that it was fine from the get-go, and I did it on my end. I'm just to sort of show you, paint a picture of what it looks like. I have to. Yeah. Okay. So let me deploy it really quick. But while that's going, any questions on the process?
I think just one thing that I want to share, Alex. I think you did a really good job of showing all of the, well, the entire process overall, and then how you can be adding your own types specifically to then once you have your compiled and live idea, once it's in your world, be able to change it through the builder tools. And I think one thing that I just especially want to reiterate is that you can use all those different types that Alex was showing to build out any idea that you that you can really imagine from the set of ideas that we already have. So a couple examples that I can think of is people have asked us for proximity model idea, which is basically what Alex just made, but maybe one way that you would want to build that for your own use case that you could then use in a whole bunch of different worlds is creating a model type in there that you can just upload your own model to. And it doesn't just have to be a hiding duck, right? You would specify it and change the name and everything like that down the road, but you could actually add the parameters right here in this idea.json file that Alex is showing to upload your own model so that you can use it for one client site, and then you can use that same idea that has all the functionality in a different client site and just swap out the model. Another use case is maybe for the speaker ideas. We currently don't have it built in, but you could create your own idea that's literally the speaker idea, but let's say you wanted to upload your own model. You could literally just copy the speaker idea code, add the functionality to be able to upload your own model, and then once Alex pushes that and you have it in your world, now you have the speaker idea, but you can change or swap out the speaker model. So yeah, I don't know. It's just I just wanted to reiterate that because I think that it's really powerful the way that Alex has structured all this to make it really easy to change and swap out models and different functionality with just a couple lines of code directly in this idea.json file.
Yeah, it definitely is. Looks easy to understand and implement, especially being able to go back to a reference point with the video.
Yeah, hopefully it is straightforward enough. And I just ran through the process, by the way, of what it looks like on my end to upload an idea to our servers. And the second that's done, and by the way, the process will look like when you're submitting the code. I'm gonna actually run this same thing and then give you an ID, and then now when you're in your world, if I'm logged in, cool. You can actually hit specify and just immediately add it to your world, and it should be good to go. Right, so now you got your duck, and you can see we had the distance parameter that's set to the radius, and I can set that to 9, and yeah, we got our duck.
Hey, drop the idea ID though. But I have it.
Idea ID. New. Idea. Yeah, any questions? So I think I just ran through everything I wanted to run through. I think it will be worth my time because we got like another hour. I'm not in a rush or anything, so I'd be down to, if you guys are interested, showing you what it looks like to make it so you can upload any model instead of just having the one duck. I'm happy to share that really quick, but for that, any questions on the process end to end that we just ran through on again, forking Muse ideas, cloning it locally, working on it, creating your development environment, your boilerplate code, and just working off of that, and then submitting a PR to ask me for review and submission to actually put it in Muse. Any questions there?
Yeah, what was the first thing that you showed for creating the environment? Like, to get it to create my like local host and get all the files.
Oh, yeah. I definitely sort of skimmed over that. To run through, and I'll actually sort of follow. So the setup here is where you would sort of follow. You need yarn, so drop that link. I'm glad yarn didn't show up. Okay, cool. Yeah, okay, so I guess you would go through this process if you don't already have yarn, but you would also need, for reference, you would need Node and npm. And once you have those two and yarn, then you're good to go. And all you have to do is once you clone the repository locally, which again just involves the process of copying the files from your forked repository into your desktop, and you have all these files here. Then using the terminal, you just run, and actually this is probably easier. Inside of VS Code, if you didn't know, you can hit this like sidebar here, and there should be a terminal there. I forget if I set that up myself or if that was already there for me. But you can also always hit terminal, new terminal, to the terminal, and then you just run yarn install. And yarn install will install all the packages for you, so that you can actually run everything. So think about that like everything to actually run the local server and React through Fiber through JS, like call it. And then the second step would be to create the idea.json and index.tsx, which again I will give you the boilerplate for. Hopefully, actually I'll probably make it so that you can just do create or yarn generate and then like a name hiding duck, and it'll just sort of create it for you, right? I think I'll sort of go along those lines, and I'll update the repo for that. And then, as long as your page is there too, which I could definitely make it part of the process to create a page, then you should be good to go. Then you should be able to navigate to, then you hit yarn dev to actually start the server, and then you're good to go. And then you can go to localhost 3000, and then whatever the path name is, decorations heading duck.
Okay.
Yeah, and again, it's laid out on the README over here. It's laid out on the README right here, the process, and yeah, I'll write a script to hopefully make it a little bit smoother to go through that. Any other questions?
Alex, if we submit ideas to the Muse Ideas repo, do we also need to add you as a reviewer for the PR?
No. So if you just create a PR, so I just created a PR. Well, technically, because I have write access, it'll show up that I can immediately just merge it if I really wanted to. But you guys will not be able to. Yeah, you can go through if you want and add me as a reviewer. It doesn't really matter. Like either way, I'll have to go through and edit it. So just ping me. What I would probably do is once you hit submit a PR, just ping me or ping anyone on Slack or on Discord, and we'll start looking at it.
Gotcha.
Cool. Do you guys want to see what it would look like to have a custom model upload?
Yeah, let's get it.
Yeah, I do personally. Yeah.
Yeah, it'll be pretty quick. You'll see. So really, all you have to do is we're gonna have a new input. It's gonna be called model. And the type, what do you know? It's gonna be. Oh wait, it's not model actually. It's GLTF. Okay. And the type of GLTF, and I have it laid out or described right here. But GLTF is a resource URL. So just so we're on the same page, when you set the type to GLTF, this is actually just a string that is a URL, right? That's all that happens. So when you have the fancy model upload input inside the builder tools in Muse HQ, that is behind the scenes, all it's doing is uploading a file, processing it, and then spitting out a URL that's just going to serve them, right? So that's relevant because in here, type for this model parameter is just going to be string, right? It's as simple as that. And as per usual, we're going to have a fallback, which is going to be able to make it deduct the fallback. So this is the backup in case you don't provide anything. And then it's also just as simple as putting a model in here. That's it. That's really all it takes, right? So just sort of follow through the where all the data is being funneled through. It's a little nicer. Yeah. So the data is funneling through the schema here is going to have a new parameter called model type GLTF, which again, when you go to upload through Muse and through the builder tools, it will just end up with the string that's a URL pointing to a file, and then that will feed into the component itself, the idea itself, which is going to be this model variable here type string, which will have a default value of this duck here. And then finally, over here in the use GLTF hook, that's where we pass in the URL to the GLTF. Right, so now if this ever changes, TF hook, this result will change, well then this result here will change. So everything kind of trickles down and will fall into place just by changing that one URL. And yeah, so I don't know the process we want to roleplay here, but let's imagine, I don't know, halfway through the submission process, you change a few things and you realize, oh, the spec, I want something a little different. You can change it. You can be like, here, let's actually pretend it happened. So we'll change both of these, and we'll say, actually, I want a custom model upload. Hit commit and push. And then over here, you see the PR because it hasn't been merged yet. So let's assume this is the step of like you're working with me, and then halfway through the process you change your mind. Feel free to do it. It doesn't really matter, and then you can just tell me, hey, actually, I need this different thing, and this will just show up in the same pull request, and I'm aware of it, right? And then let's say, okay, I go, okay, sounds good, and then I let it go by. I'm going to do my thing again and go ahead and upload it, which is this little process here. This is exactly why it hasn't been automated yet, because this process is kind of annoying. But so this is what I would be doing on my end, right? Which will give you a new ID. Now this is the ID associated with the new version. This is the new schema, and it has it all wired up correctly. And once it finishes building, just a sec here, you'll be able to immediately start using it in your code. Give me a second. There you go. And then now I can delete this and add the new one that I wanted to. And it'll still have the duck, right, because that was the fallback, but now there's a new field, so it's model, right? It's wired up the same way that all of our other inputs are wired up, and then you can just, I don't know, put a basketball there, and cool, it works the same, right? Or I can upload an ATM. Beautiful. Pretty straightforward stuff. Cool. Any questions on that process?
No questions.
Cool. Yeah, again, like I said, I imagine a lot of the questions will come up when you guys actually start to develop your own ideas. And I want to be able to, I don't know, render 10,000 things at once, right? And now we start to get into like heavy 3D topics. React through Fiber your JS specific things, by all means, feel free to reach out. Like, I'm happy to talk tech. That's that's what I love doing. So, yeah, don't be afraid. And yeah, also again, don't be afraid to submit PRs, no matter, because we can always go back and forth. If you guys have never worked with the PR, there's really cool functionality where I can actually go in to the code that you submitted and add comments, something like, I don't know, I can say it's no longer a duck, change the name, right? And I can start a review, and then that's like a really easy way to go back and forth between us on like things you need to change, things that I'd recommend against. If you can even leave a comment saying, hey, how do I do a certain thing here? And I can add like, let's say like sample code, use a limiter here, or use limited frame, right? So yeah, again, I guess just coming full circle, this entire process that we designed, sort of rough around the edges, is sort of made so we can work together, really get any ideas that you guys need out for your client to get pushed live onto Muse. And you saw once the code's more or less fine, it takes about a minute to upload and directly start using in Muse, right? So yeah, don't be afraid to start building.
Nice. Okay.
Amazing. I'll sit around for one or two more questions, but yeah, I'm all done with my material.
Thanks for that, Alex. I'm going to stop recording here, and then maybe if there's any good questions that we have after, then we can add it to notes or something like that.